variables, we have been saying or I have been saying all along, that if there's two different letters, for example like this, that we can't solve it to find out what they are because there's an infinite amount of possibilities that it could be. This could be 4 plus 1, 3 plus 2, 0 plus 5, 6 plus negative 1. Right? There's an endless amount of possibilities, so there's not a way to solve it. What we're going to be starting to look at in this chapter is how could we solve something like this, or what can we do with this type of equation? So when I talk about two variables, I mean two different letters. Okay? So an x and a y, an a and a b, whatever it might be. Now, most of the time we use x and y. We are going to be doing some graphing in here. So as a reminder, an ordered pair is one name for this. It's also sometimes called a coordinate pair. I believe your book is going to call it an ordered pair, though. So remember, that would be for the point on a graph. The x, of course, being across, and we're going to get more into this part tomorrow, but the x-axis and the y-axis, right? And that stuff we've done already. Now, if an equation uses letters other than x and y, a and b, f and g, whatever they are, if you were thinking of it in terms of this graphing kind of ordered pair, just use them in alphabetical order. X and Y are in alphabetical order. If it was A and B, it would go A, then B. So even if other variables are used, it can still match this as long as you keep it in alphabetical order. Now, what you're going to be given today to start with is you'll be starting with an equation. For example, 4x plus 3y equals 10. And then you're going to be asked whether a particular ordered pair is a solution. So for example, 4, negative 2 as our first pair. Is 4 negative 2? When I say it, I mean this ordered pair. What it means by it being a solution is you plug in the x and y values. Does it make a true statement? So we look at the equation we're given. We're going to take the ordered pair, remembering that the first number is the x and the second number is the y. We're going to plug these numbers in to the equation for the x and the y. If this is a solution, your answer will be yes or no. Is it a solution? Yes. Is it a solution? No. That yes or no comes from this question. Does it make a true statement when we plug them in? So let's try it on this first one. If my x is the first variable, or the first number, 4 times x, 4 times 4, right? Here's my x, here's my y. I just copy the rest of the equation. Plus 3 times y. Well, now I'm going to try this negative 2 for the y. So I just replaced the x and the y with the values from that ordered pair. And now, just remember to follow PEMDAS. We need to do our multiplication first. I get 16 plus negative 6 equals 10. Is that a true statement? Yeah, we could even take it further. We could solve the left side. 10 equals 10. That most definitely is true. So your answer for this, yes, it's a solution. And you don't need to make it exclamatory unless you want to. Yes. So I'll show you an example of one that doesn't work. Using the same equation, we're going to stick with 4x plus 3y equals 10. Let me give you another pair, and we'll plug it in. For some of these, you will be given two pairs, two ordered pairs, for the same equation. So you plug them both in, you try them both. So I'm going to try this into the same equation. It was still 4 times x, now my x is 3, plus 3 times y, my y is now negative 1, equals 10. So my equation doesn't fit on the page anymore, but it was that same one we started with for the first example. Let's see if this one is a solution. Again, looking at PEMDAS and what I need to do first. 12 plus negative 3 equals 10. If we want to finish simplifying the left side to be certain, 9 equals 10. No, that is not true. 9 does not equal 10. So if you get something that's not a true statement, like 9 equals 10, Is that pair a solution? No. So that's going to be the first thing you're going to see in this lesson. Not too hard, hopefully. Testing out different pairs. Now first let me just say, if it is a solution, here's what's going to happen. This graph, if we were to graph this, which we will be doing, I believe, tomorrow, it would make a straight line. If it is a solution, it means this point is on the line. Okay? If it's not a solution, it means that point is not on the line that we graphed. Okay, we've done some of that graphing of a straight line. Now, the next thing I'm going to show you, the other thing you're going to see today, you've seen something similar. We're going to use it in a slightly different way. You are going to get an equation, for example, y equals 3 over x plus 1, so just to make it look a little different. And your question is going to say, let me put this above, solve if x and y are whole numbers. It's hard to graph fractions and decimals. So here's what we're looking for. We're going to try to find, now this chart that I'm going to add should look familiar. We have done this. We did this in order to graph. We would pick a value for x, we'd plug it in, we'd get out the y, that would be a point we could graph. Okay, so we've done that, and we will get back to that. So hopefully that background will help, since we've already done some of that. But here's the slight difference that we're going to look at here. If I was going to graph, I don't want to get fractions and decimals. Solve if x and y are whole numbers means we need to find all the possible pairs that work. There's not an endless amount, don't worry, that are only whole numbers for both x and y. So let me show you what I mean. Let's start. Now, and by the way, when I say whole numbers, I also mean only positives. We're not going to worry about negatives, and I don't want decimals or fractions. So we always are going to start with 0. We're going to pick values for the x. We only keep them if the y value comes out to be a whole number. So let's try it. Y equals 3 over 0 plus 1. Okay, well 0 plus 1 is 1. If I have 3 over 1, well that simplifies to 3. Oh, there's a whole number. So my first pair of 2 whole numbers worked. There's one solution. Solve means, and I'll put a little note up here, find all possible solutions, which would be these xy pairs. Now again, when I say all possible, we're only talking about positive whole numbers. So there you will, I'm going to show you here, you should start to see a pattern, and then you'll know when you can stop. Okay, so when it says solve, it means find all the possible solutions that are xy's that would work for this equation that are positive and whole numbers. So for example, if I, after 0, my next whole number, okay, 1. Let's try it. Y equals 3 over 1 plus 1. That's 3 over 2. Is that a whole number? No, I'm going to stop. If it is not a whole number, I could see 3 over 2, that'd be 1.5. I'm not even going to finish it. I'm going to stop because I don't want a 1.5 or a 1.5 or a 3 over 2. I don't want it if it's not a whole number. So let's try our next whole number. After 1, let's try 2. Y equals 3 over my x plus 1. 2 plus 1. Hey, 3 over 3. That's a whole number. That makes 1. There's my next solution. I'm going to try one more, and then I'll show you that you'll realize you don't need to do any more. And I will tell you for the homework, I'll tell you how many solutions there should be. On number 10, there should be 4 solutions. On number 12, there should be 2. I'll give you that information when we get started for the homework. Let's just try one more number, and then hopefully you'll be able to see that we don't have to do any more. We go to our next whole number, 3. 3 over my x, 3 plus 1, I get 3/4. Not a whole number. Let's take a look at the pattern of what we've got. Look at what happens in each of these. As my x gets bigger, look what happens to my denominator. 1, 2, 3, 4. It gets bigger. When I go to my next number, what would the denominator be? Jaden? 5. And my numerator is always going to be 3 in this particular equation. My numerator doesn't change. It's always just plain old 3. So then I'm going to get 3/5, not a whole number. Then 3/6, not a whole number. 3/7. I will never again get a whole number. Does everybody see that? That there won't be any more whole numbers because the denominator keeps getting bigger. 3/4, 3/5, 3/6, 3/7. Those are all fractions. It's going to stay fractions from here on out. As soon as you see that pattern, you go, oh, there's not going to be any more whole numbers. There are my 2 solutions. What you have to do is start to look for a pattern of which numbers for x are making a whole number answer. Once you see the pattern, you can start skipping some. If you could do this 1 in your head and realize it's not going to work, or the 3, then you don't even have to write them down, as long as you're being careful and not missing any that do work. That's it for today. So, let me give you your work.